Good evening. Well, I guess for you guys this morning. We're going to be going over some of these. I know you guys had a couple minutes to work on it in class the other day. Hopefully, you held on to them. But originally, I was going to do all of these, and instead, I think I'm just going to maybe do the odds. So, start off with number 3. Now, notice that it specifically states here that we're putting this in slope-intercept form. Hey, Cleo. This is my cat, Cleo. She will probably be making numerous appearances in this video as my vocal backup. There's Bullseye just jumped onto my lap, too. Cleo, sweetie, what? Okay. So, here we go. So we have y. We're trying to put this in y equals mx plus b, right? Now, what we're going to do mainly here is go from, I'll just kind of draw it over here. We're going to take the point that we're given, the slope that we're given, and what form of the line do you think we're going to put it into? That's right, point slope. What does point slope looks like? Well, you have your point over here, x1, y1. You have a slope over here, it's m. And then you do this. And then to go from point slope to slope intercept, you distribute the m and solve for y. Let's show you how it's done. So here we have 0, 3. Some of you may find a shortcut on this one, and that's okay. I'm going to go through the steps that I just explained. So this is my point, x1, y1. This is my slope. So we're going to go y minus 3 equals negative 2 times x minus 0. So this gives us y minus 3 equals negative 2 times x. We're going to add 3 to both sides. We get y equals negative 2x plus 3. Easy peasy. Let's look over at number 3. Number 3 going to be a little bit more tough. But same general idea. That's our point, x1, y1. This is our slope, m. So again, we're using point slope. Y minus y1 equals m times x minus x1. It's going to go y minus 6 equals slope 1/4 times x minus, now watch what happens here, we're putting a negative 8 in there. So we end up with y minus 6 equals 1/4 times x plus 8. Very much like the other formulas we had where negatives were built in. It's important to understand that these negatives, the y minus y1 and the x minus x1, are built into the point slope form. So now we want to distribute that 1/4, our slope. And so we end up with 8 times 1/4. Rama, shush. So 8 times 1/4, how do we multiply a whole number by a fraction? Well, we turn our whole number into a fraction by putting it over 1. Remember, we can divide anything by 1, and it doesn't change its value. 8 divided by 1 is still 8. But now we have it in a fraction value instead of a whole number. Then we multiply across the top, multiply across the bottom, and reduce. We're then going to add 6 here to both sides. And we end up with y equals 1/4 x plus 8. Okay. Number 5. Again, we're doing odds here, so if you're looking for a specific one, then just look for one near it that I've done, and that should give you, basically the form for how you're going to do this. So I'm going to write over here in number 4 the steps we're going to take. Now, we're actually not going to do number 4. I'm just going to write down the steps, and then I'll follow those steps for number 5. So we're going to find the slope between the points. And that's, remember, slope is y2 minus y1 over x2 minus x1. Then we're going to go use the slope and 1 point for point slope form. And then using the exact same steps that we just used, we're going to place in slope intercept. And that's going to be distributing our slope and then solving for y. Okay, so here we have x1, y1, x2, y2. And I know I've done this before, but I'll quick do it. It doesn't matter which way you do it. If this was x2, y2, and this is x1, y1, you're going to get the exact same. I will quick do both ways just to show you that. So remember, slope is y2 minus y1 over x2 minus x1. So we have -1 minus 4 over 6 minus 1. It's going to be -5 over 5, or a slope of -1. It's very ominous by one of my cats on the piano. So that's -1. Now watch what happens if I do it the other way around with the red numbers, x2, y2, x1, y1. We're going to have 4 minus a -1 over 1 minus 6. 4 plus 1 is 5. 1 minus 6 is -5. 5 divided by 5, -5 is -1. See, we get the same slope here or here. So that's step 1. The second step, use slope in 1 point for point slope form. So I'm just going to pick 1, 4. I will do it with 6, -1, just to show you it doesn't matter which way you do it. So remember, point slope is y minus y1 equals m times x minus x1. This is going to be y minus 4 equals -1 times x minus 1. We're going to distribute our m. And then solve for y. This is going to give us y equals -x plus 5. Now, what if I had chosen 6, -1? Well, I would have gone y minus a -1 equals -1 times x minus 6. Y plus 1 equals -1 times x is -x. -1 times -6 is +6. And then subtract 1 from both sides, and lo and behold, I get -x plus 5. And And I need to go grab my charger. Hold on just a second. Okay, so everything's all charging now. So once we get to 7 all the way through the rest of them, we kind of have the same general plan we're given, and this is what we worked on today, or rather yesterday, for you guys. So the equation of a line that is parallel to the line y equals 3x plus 6 and passes through the point 4, 7. Remember, I gave you the steps. So the first thing we want to do is take the given line and find its slope. Now, lucky for us, here on number 7, it's already in slope-intercept. Remember, that's y equals mx plus b. So right here, my slope is 3. We're looking for parallel. We know that parallel lines have identical slopes. So we know that the line we're looking for, so step 1, step 2, step 3 is identify the slope that we're using. Here, our slope is going to be 3 again. If it's parallel, it's the same. If it's perpendicular, it's the negative reciprocal. So that brings us to step 4. Step 4, we're going to take the point given, the slope from number 3. We're going to put it into point slope form. Again, point slope form is y minus y1 equals m times x minus x1. So this is going to give us y minus 7 equals 3 times x minus 4. So that's step 4 right there. Step 5, we're going to solve for y. We're going to do the exact same things we were doing in 1 through 6. We're going to distribute this 3. 3 times x is 3x. 3 times negative 4 is negative 12. And we're going to solve for y. So we're going to add 7 to both sides. And we end up with y equals 3x minus 5. And that's how you do that. So on to number 9. So for number 9, equation of the line is parallel to the line of 5x minus 4y equals 4 and passes through the point negative 8, 2. So here, step number 1 is a little bit more tricky because we want to take this line right here. We're going to plug it in and we need to find the slope. So we're going to put that into slope-intercept. This is standard form. And we want it to look like that. So we want to subtract 5x from both sides. That's going to give us negative 4y equals negative 5x plus 4. And then we're going to divide everything by a negative 4. Remember, what we're trying to do is get it to look like y equals mx plus b. We don't want to solve for negative y. We want to solve for y. And when we divide one side by negative 4, divide everything by negative 4. So we're going to put y equals, now negative 5 divided by negative 4, it's going to be a positive 5 over 4. Now some of you guys are going to be tempted to sit there and write that down as 1.2, which is okay, and not wrong per se. But keep in mind, that when we're talking about slope, we're talking about a fraction. We're talking about a ratio of rise over run. So leaving slope in a fraction form is actually a lot more helpful. So, not what I want to do. So, step 1, put it in slope-intercept form. Step 2, identify the slope. Remember, this is y equals mx plus b, where m is the slope. So now the slope of the given line is 5/4. Step 3, identify the slope of our new line. So we're looking for this new line that is parallel to this line and goes through the point -8, 2. So remember, parallel lines, same slope. So we're just going to copy that slope. I'm going to go off on a little bit of a tangent here. I know you thought you'd get away from tangents with me not going there, but nope. So what we're going to do is we're going to start off, and what I want to show you is what it would look like if it was perpendicular. So remember, perpendicular is the negative or opposite. Reciprocal we're going to pretend I spelled that right, of the other slope. So if we knew that the slope of the given line was 5/4 and we wanted the perpendicular line to that, we would take 5/4, we would flip it upside down. That's what reciprocal means. And then for the opposite or negative, we just change the sign. So these two would be perpendicular to each other. 5/4 slopes of 5/4 and -4/5 would be perpendicular to each other. And that's how you'd solve that. But we're not looking for perpendicular here. We're looking for parallel. Parallel means they're the same. So then we're on to step 4. Remember, step 4 says take the given point and the slope from number 3 and plug it into the point slope form of a line. So we go y minus 2 equals 5/4 times x minus a minus 8. So we have y minus 2 equals 5/4 times x plus 8. Okay, so now we go on to step 5. And in step 5, all we're doing is returning the rather non-specific. Remember, we went over this in class. There are an infinite number of different point slope forms for any given line because there are an infinite number of points. So you can make any one of those points and make a point slope form out of it. There's only one standard form and one slope intercept. Again, we don't really use standard form until algebra 2. But we are going to be using slope intercept here in geometry as kind of our go-to form of a line. In my opinion, it is the superior form of a line for a variety of reasons. But that's what we're going with here. So we want to distribute that slope. 5/4 times x is simply 5/4 x. And then we're going to go 8 times 5/4. And remember, when we have a whole number times a fraction, we put that whole number over 1 and multiply across. So we end up with 40/4, which is 10. We're going to add 2 to both sides. And we get y equals 5/4 x plus 12. So that is the line that is parallel to this line right here, 5x minus 4y equals 4, and it goes through that point. Okay, on to number 11. Oh good, perpendicular. Not that perpendicular is particularly hard or anything, I just want to make sure that we do at least one of them where we have it perpendicular. So perpendicular to the line, and then they give us this line. So remember, step one is we're going to take the given line, which is in standard form, and we're going to turn it into slope-intercept form. Specifically, we want to find that slope. If we're looking ahead, we know our slope is step 2. So we take 5x plus 6y equals 18. And we're going to subtract 5x from both sides. So we end up with 6y equals negative 5x plus 18. Got to get rid of that 6, so we're going to divide everything by 6. We end up with y equals negative 5/6x plus 3. And this right here is our slope. So our slope is negative 5/6, and that's step 2. Step 1 was just simply getting it into slope-intercept form. Step 2 is finding the slope itself. We're going to take that negative 5/6. And remember, now we're looking at step 3. Step 3 says if it's parallel, we take the same one. If it's perpendicular, we take the negative reciprocal. Here we're looking for perpendicular, so we need that negative reciprocal. So we're going to take negative 5/6, and we're going to flip it upside down. Negative 6/5. And then we change the sign. And we multiply by negative 1. Since we already have a negative here, that's going to turn this positive. So the slope of any line with a slope of 6/5 is going to be perpendicular to this line right here. We solved the first part. So now what we need to do is we need to be more specific. There are an infinite number of lines that are going to be perpendicular to that one. We need the one that goes through this specific point. That's where step 4 comes in. We take the given point, the slope we just found from number 3, and we plug it into slope-intercept form. And by slope-intercept, I mean point slope. Sorry. Y minus 7 equals 6/5 times x minus 10. Okay, that's step 4. All we need to do is put it into point slope form. Step 5 is we're going to take that equation we just used, which is an equation of the line, but it is an imperfect one. We want to be more specific, so we're going to turn it into point or slope intercept. And again, to do that, we're going to distribute that slope. We're going to go 6/5 x minus, we're going to go 6/5 times 10. Again, when we multiply a fraction by a number, we put that number over 1. Then we multiply straight across. 6 times 10 is 60. 5 times 1 is 5. And then we grab our calculator and go 60 divided by 5. And we get 12. So then we're going to take this, we're going to add 7 to both sides. And we're going to get y equals 6/5 x. That's our slope, minus 5. And that's our slope-intercept form. Which brings us to the last two. The These are tricky. If you finish everything else in class, I do want you to try these. So let me show you how it works. CD, that's segment CD, is formed by this. If a line is perpendicular to it, write a linear equation for t in slope-intercept form. So CD is formed by -5, 9 and 7, 5. Okay, so just if we were to graph this, -5, 9 over 7, 5, we're looking at this. Okay, if line T is the perpendicular bisector of CD, write a linear equation for T in the slope-intercept form. So we got a lot going on here, okay? So sit down, strap in, pay attention. So first, notice perpendicular and bisector. And that right there gives us all the information that we need to know. So we need to know that it's perpendicular, but more importantly, it's the bisector, means it cuts it in half. So that means that's going to tell us, because if we look at this right now, it says, well, where do we go through? On all these other ones, 8, 9, 10, 11, 12, or 9, 10, 11, 12, we were given the point that it goes through. We're not given that point directly, but we are told how to find it. So we're going to go x1, y1, x2, y2, and we're going to find the midpoint. Remember that the bisector is going to go through the midpoint of any segment. Remember that our midpoint, and you guys should know this because, every Monday you've been reviewing all your notes for the entire semester. So you guys should have looked over the midpoint formula, almost 10 times? Plus all the time that you used it back at the beginning. This should be old hat. I'm laughing hysterically over here because I know that you guys don't actually do that, much to my dismay. Anyway, XMYM is x1 plus x2 over 2 and y1 plus y2 over 2. This is going to give us our midpoint of this segment. So we're going to go -5 plus 7 divided by 2, 9 plus 5 divided by 2. -5 plus 7 is 2. 9 plus 5 is 14. So that gives us a midpoint of 1, 7. Okay? So this is the point when we talk about step 4 of what we've been doing. And we talk about take the given point and the given slope, figure it out. Now we know that point. It's got to go through 1, 7. 1, 7 is the midpoint of this segment. So now we have to cheat a little bit. We don't need to find the exact equation of the segment of CD. Rather, we just need to find the slope. We know that slope is y2 minus y1 over x2 minus x1. That's going to give us 5 minus 9 over 7 minus a minus 5. Let's give us -4 over 12, because 7 plus 5 is 12. -4 over 12 reduces to -1/3. Okay, so that's step 2 right there. We found the slope of our reference line, or in this case, reference segment. So now we need to go on to step 3. Step 3 says find the slope of the line you're trying to work on, the new line, so to speak. So what we do here is we take our old slope and we go, hey, it's perpendicular. If it was parallel, we just copy it down. It's perpendicular, so we need the negative or the opposite reciprocal. We're going to flip this upside down. To get to -3/1. and then we're going to apply the opposite to it, or the negative to it, and that gives us a positive 3 over 1, or just 3. So now we've reduced what was really this pain in the butt problem to write the equation in slope-intercept form of a line with a slope of 3 that goes through 0.17. And it looks like a lot, but really all we did was the slope equation and the midpoint equation, stuff that we've done literally dozens of times before. So now we go on to step 4. With this information, we're going to plug that into our good friend point slope form. So we're going to go y minus 7 equals 3 times x minus 1. Okay, and that's step 4. All we had to do was plug in the point into our x1, y1, and plug in the slope into our m. Step 5. We're going to start off with distributing our slope. So 3 times x is 3x. 3 times negative 1 is negative 3. And then we solve for y. We're going to add 7 to both sides. This is going to give us y equals 3x plus 4. And that's it. That is all of the odds. There are a couple of evens lying around, but you guys can pick those up. No problem. Go steady. Go slowly. Make sure you're showing your work. Make sure that you understand what it is that you're doing. And if that doesn't help, look at your notes. If that doesn't help, you're watching this video. If this doesn't help, try and ask, someone in the classroom who looks just to be flying along. So thank you all. I will see you all tomorrow, and I hope you all have a wonderful day.